Welcome to chemistry, guys. Today we'll be taking balancing of redox equation in acidic and basic medium. Now, redox equations, they are more complex than your basic regular chemical reactions, but follow the simple steps and it will be simplified to you. What method we're going to use is we're going to use the half equation method. For example 1, we have this two equation. Yes, it's a redox reaction because there's oxidation and reduction going on. The chromium is being oxidized and the nitrogen is being reduced. So step 1, separate the half reaction. This means the reaction will be separated into the two different compounds, which is chromium being oxidized and nitrogen being reduced. Step 2, balance elements other than oxygen and hydrogen. Yes, so we're going to balance every other element without touching oxygen and hydrogen. Now I'm going to balance my chromium. I have 2 molecules of chromium here. I'm going to balance it by putting 2 here to make it 2 molecules of chromium and 2 molecules of chromium on the right and left hand side. I have 1 molecule of nitrogen here. Therefore, nitrogen is balanced. Next step is I'm going to balance my oxygen with water. So I have 7 molecules of oxygen here. 7 molecules. I'm going to add on the right hand side 7 molecules of water to balance the oxygen. For the second reaction, which is nitrogen reaction, I have 2 molecules of oxygen here and 3 molecules of oxygen at the right hand side. Therefore, to make the left hand side balance, I'm going to add 1 molecule of oxygen to the left hand side. To make the left hand side 3 molecules of oxygen and the right hand side also 3 molecules of oxygen. Therefore, step 4, balance hydrogen. So step 1 is separate the reactions. Step 2, balance every other element. Step 3, balance oxygen using water. Step 4, balance hydrogen by adding the proton H+. Now we see that we have 14 molecules of hydrogen here on the right hand side. To balance it on the left hand side, we're going to add 14 molecules of hydrogen proton. For nitrogen, we have 2 molecules of oxygen here and 1 molecule of oxygen here on the left hand side, making it 3 molecules of oxygen. We're going to balance that on the right hand side by adding 3 molecules of hydrogen. Therefore, hydrogen is both balanced on the right hand and on the left hand side. Let's go. Now, after you've balanced your elements and your compounds, we are going to balance charge. So you balance your element first, your compounds, then next thing is to balance charge. Therefore, to balance the charges, we have 14 plus 14. This is 14 plus and minus 2. You know, when you see charges at the top of elements and compound, it means that those are the charges of the elements or the compound respectively. Therefore, we have plus 14 plus minus 2 from the chromium oxide to give us a total charge, a total net charge on the left hand side of plus 12. That's for the left hand side. Now on the right hand side, we have plus 3. Water is neutral because it doesn't have any charge, therefore it's neutral. Plus 3 on the right hand side. 3 is 3 times 2. 3 times 2 to give us a net charge of plus 6 on the right hand side. Therefore, the left hand side has plus 12, the right hand side has plus 6. To make this charges balance, we are going to add 6 electrons on the left hand side to neutralize this 12 plus 12 charge. Therefore, the left hand side, now the total net charge is going to be plus 6 on the left hand side, and the total net charge on the right hand side is going to also be plus 6. For the next reaction, which is nitrogen reaction, this guy over here is 0, water here is 0. Therefore, the net charge on the left hand side is 0. But on the right hand side, we have minus 2 and plus 3. Therefore, plus 3 plus minus 2 from nitrogen oxide is going to give us a net charge of plus 2 on the right hand side. But the left hand side has a net charge of 0. Therefore, to balance these charges, we're going to add plus 2 electrons on the left hand side to neutralize we're going to add 2 electrons on the left hand side to neutralize the plus 2 charge over here, therefore giving us a net charge of 0 and 0 on the right and on the left hand side respectively. Now the reason why we use electrons is because in a chemical reaction only electrons are transferable. Protons are not transferable apart from a higher reaction called radioactive reaction. That is for higher chemistry, not for chemical reactions. Moving on, please. Step 4. Yes, we're going to the end. Step 4 says scale the reaction so that the electrons are equal. What this means is that the electron here, the prefix, which is 6 and 2, on the electrons of the two reactions must be the same. But here is 6, here is 2. Therefore, we are going to make this electron here 6. And how are we going to do that? We are going to multiply this equation by 3. Multiplying it would have this as our final reaction. Therefore, 3 here, 3 here, 9 here, because 3 times 3 will give us 9. 3 here and 6 here. Now, the purpose of this is so that the electrons would cancel out. Add the reactions and cancel out common terms. This is my reaction 2. This is my reaction 1. I'm going to add them together. Those on the left hand side will be added together. Those on the right hand side will be added together. Then I will cancel out like terms. I have 6 electrons on the left hand side. We'll cancel out 6 electrons on the right hand side. I have 3 molecules of water on the left hand side. We'll cancel out 3 molecules of water here, leaving us with 4 molecules of water. Then I have 9 molecules of proton. So cancel out 9 molecules of proton here, leaving us with 5 molecules of proton. Therefore, this will be my final reaction. Yes, this will be my final reaction. Now note, this is an acidic reaction. It's an acidic, this final reaction is acidic. It is acidic. That is why we have basic conditions. Basic conditions simply follows all your acidic. It follows the step 1 to step 7 of your acidic solution or condition. But the difference is that for step 8, basic condition as step 8, that's where the basic, that's where OH minus is introduced. For your step 8, we are trying to neutralize in the basic condition. For example, if I have to carry this further to basic condition, in basic condition, we're trying to neutralize the H plus. We're trying to neutralize the H plus, therefore shifting the reaction to either a neutral equation or a basic equation. So the essence of basic condition is to neutralize the H plus in acidic condition. Follow me, please. Let's take an example. Let's take a fresh example so that you would understand the steps again from step 1 to step 7. We have this as our equation. Step 1, separate into half reactions. Therefore, we are separating the reactions to silver and to zinc. Step 2, balance elements older than oxygen and hydrogen. Therefore, our silver, we have 2 molecules of silver here. We're going to add 2 here to balance the molecules of silver, and zinc is balanced already. Add water to balance oxygen. We have 1 molecule of oxygen here. We're going to add 1 molecule of water here to balance the oxygen. Step 3, balance hydrogen. Now, over here, we have 2 molecules of hydrogen. What are we going to do? To balance it, on the right hand side, we're going to add 2 molecules of proton. Therefore, hydrogen is balanced. Now, zinc doesn't have a problem. So after we've balanced the elements, or we've balanced all the elements, we are going to start balancing the charge. Now, for silver, we have 2 plus 2 charge on the right hand side, but you see on the left hand side we don't have any charge. We have 0 charge because these 2 compounds are 0. Therefore, to neutralize this plus 2 charge, we're going to add 2 electrons on. We're going to add 2 electrons to neutralize the plus 2 charge. And for zinc, we have plus 2 charge on the left hand side. To neutralize this, we're going to add 2 electrons there. After balancing that, we're going to scale the reaction. Scaling means that the electrons for equation 1, the prefix of the electron for equation 1 and equation 2 must be the same. And in this case, it is the same because they have 2 and they have 2 as their prefix. Therefore, add the reactions and cancel out elements. So we're going to add the reactions and we'll cancel out similar elements. Therefore, the electrons has been cancelled out. And this is our equation for step 7. If we were dealing with acidic condition, this would have been our final equation. But no, we are dealing with basic condition. And remember, I told you the essence of basic condition is to cancel out, to rule out, to neutralize this H plus. Therefore, basic condition as step 8. This is where the basic condition begins. Step 8 says add OH minus to balance H plus. Therefore, we have two molecules of H plus here. We're going to add two molecules of OH minus to both the left and to the right hand side to give us this equation. So you see that our OH minus has been added to the left hand side and also added to the right hand side. We have two molecules. Why? Because H plus is two molecules. Now, combine step 9 says combine OH minus and H plus ions together to form water. Remember, neutralization is the formation of water when acid and base, when OH minus and H plus react. The same goes for here. These two guys are going to react, H plus and OH minus. They are going to react to form water. And we don't have any H plus to react with this OH minus. Therefore, it's going to be left. Now, after that, we're going to cancel out like terms. We have two molecules of water here. We have one molecule of water here, cancelling out one molecule of water here, cancelling out one of this water to give us a final equation of this. Therefore, we have this is our final equation, and this is for basic condition. Now, this equation is a base because we have our OH minus is still here. It's a base. If only we add an H plus, like an H plus proton on the left hand side to neutralize this guy, it's going to give us a neutral equation, but we don't have an H plus. That's why it's a basic equation. So thank you so much guys for watching, and I'm going to see you in the next video.